All right. Hi, friends. Hi-Fri here. Um, so I just wanted to revisit the Hidizs MS5. Um, this is a really nice IM, and in my review, I didn't really give it the best review, but I do want to take the time to highlight its construction because I think it's a very novel design. I think it's very beautifully constructed, and it has good parts. So I want to take it apart and kind of show you guys the construction of the IM, and maybe talk a little bit about the tuning and how the tuning works. So for the MS5, so obviously it's a 5 driver IM. It's one dynamic driver and 4 balanced armatures. We see here MS5. So anyway, you'll notice firstly that we have a Knowles style dampener on the top here. Now we'll just grab my little removal tool, try to pull this out. Okay, so there is a little hollow cavity inside there, and this has to do a lot with the tuning of the IMs. So this little dampener here controls the amount of bass and not only the amount of bass, but the I'm sorry, lower mids as well. So as far as bass, the way these IMs are set up, so you have a 10 millimeter dynamic driver for the majority of the bass. That's like the sub bass, and it covers the majority of it. And then we have a balanced armature for the mid bass, and then one balanced armature for mids and one balanced armature for treble. And the way it is set up is the dynamic driver and the BA driver for the mid bass share the same cavity. So this entire cavity is essentially a resonator, like a chamber. It's a speaker per se, and you guys will get to see. Whoops, you'll get to see how the sound emanates from those two speakers and kind of mixes inside this cavity and then shoots out the nozzle here. So we'll go into that in just a second. But yeah, so if you want to, for whatever reason, if they have too much bass, you can remove the dampener on top here. If you add a higher value of dampener, you will get less bass, and with a lower value of dampener, you will get more bass. So technically, if you wanted to, you could remove this and you'll get more bass. It's really strange. But yeah, oh, that's what I wanted to say. So the way it works is this, and I'll show you this hole down here goes straight into the dynamic driver, and this is what is controlling the dampening for the dynamic driver. So we'll see. It's a very, very novel design, very crazy, and sort of difficult to tune, with everything being inside the shell. Honestly, if you wanted a really good way to tune these, you would have to bring all the wires out through this hole here and have like the crossover sitting outside, and you would have to tune it that way. Now there are a couple disadvantages to this design, a couple quote unquote mistakes that I think Hidizs made, and one of those being the the dampener on the front here. So let me just demonstrate. So this is the treble balanced armature right here, and there is no dampening whatsoever. So what happens is you get a lot of BA timbre, and you also lose control in the upper treble. Balanced armatures naturally, because they have a lot of weight on them because they're balanced. So you have a rod with a coil around it and two magnets, and then you have the diaphragm itself, and you have a rod that connects the two. So when the coil is activated, and it moves against the magnetic field, it pulls the rod and pulls the diaphragm back and forth. So you have all this weight moving back and forth, and sometimes they can overshoot. Also, because the material is metal, it's a little bit stiffer. So when it does move, it needs dampening, because there's like resonances and stuff inside there. And anyway, I don't know all about BAs. Like I can't really tell you exactly what the science is, but BAs naturally need dampening, or else you're gonna have some pretty aggressive timbre. And these definitely have some BA timbre, even though they're Sonian. So it really speaks to Sonion's BA quality that the treble is as good as it is. Because if you were to use an inferior balanced armature like a Belzing or a E Audio or whatever, um, it wouldn't sound nearly as good without a dampener. It would probably sound a lot worse. It depends. I should give them more credit because E Audio and Belzing have come, at least E Audio. I'm not sure about Belzing, but they've come a long way with their treble balanced armatures. For example, um, oh shoot, what is it called? Oh, the CVJ May. I'm sorry, the CVJ May uses like hardly any dampening, and that custom balanced armature is a I believe a E Audio, and it sounds. I think it all sounds better than the Knowles balanced armature. I mean, it sounds really good, and there's like very little dampening. But you can tell there's definitely a lot of BA timbre, but the resolution is good, and the sound is not aggressive. It's not like BAs of past with like KZ and stuff where there was a lot of metallic timbre. It's not like that anymore. They sound way cleaner. But anyway, long story short, so we have this little hole here, this cavity. So you'd think, okay, well, I can just put my own dampener in there, and change the tuning. Nope, it doesn't fit. These don't fit. This diameter here is too small, and the only way that you could actually put any kind of dampening in is if you take this little metal cylinder here and you push this mesh out, so you can actually push the mesh out. But it's so finicky. You'd have to push the mesh out, put it around, something like these tweezers, and then you would have to carefully insert the mesh without it getting all bunched up. It's just a pain in the ass. But anyway, um, so it would have been nice if this was a little bit larger to accommodate a dampener, or if they installed a dampener. Um, but anyway, they didn't. And then up here, further up, this is our mid balanced armature. This is our 2389. And you'll see there's a white dampener in there. It's the same value as this one right here. Um, but yeah, this just dampens the mids, makes the mids a little bit smoother. That's one reason why the mids are so much smoother than the treble, and why the treble is a little bit fatiguing. Also the crossover point. But yeah, there's a few issues with this design, but anyway, so then we have this little hole right here to the left, and now this hole to the left, this is where the bass emanates from. It comes from this large cavity in here where the dynamic driver and the balanced armature mix. So anyway, oh, and also, so another thing to mention is this dampener here. You think that you would be able to remove it, but nope, you can't. It's not. It's glued in place. It's not removable. This whole cavity here, I don't know why they say it's silicone. It's not silicone. It's 3D printed plastic. It has nothing to do with silicone. It's this whole chamber here is 3D printed plastic. So, anyway, let's open it up. So the back plate comes off. It's a completely sealed back plate. There's no venting. In order for this design to work properly, it has to be completely sealed. So they have glue all the way around it. And then this back plate here, this is just for decoration. So it looks nice, but yeah. So it's not open back. There's no venting in the back. And upon first glance, we are greeted with a few different things here. So let me just point out everything to you. So this is the dynamic driver. The front of the dynamic driver is right here. This is where the bass comes out and kind of mixes in with everything. The back of the dynamic driver is right here. and we'll see in a minute, but there's a tube that is attached. It's glued on. It's like cut to fit the back here, so it's like cut to fit perfectly, and then the tube runs up, and that is what this is right here. So this is the tube that runs down into the dynamic driver. And then to the left of that, we have our 17A003. So this is our mid-bass balanced armature. Now all this wiring here, this is nice high quality wiring. This is Litz cable, so this is very expensive cable. It's like 15 bucks for a meter or a couple meters. It's not cheap, and this is like some of the highest quality wire you can use, other than the silver, like 7N silver cable, which I have some of that too. But anyway, so this balanced armature here, you'll note, you'll just barely see it. Let me move these wires out of the way. So you see the nozzle right there. There's nothing attached to that nozzle. This balanced armature fires into this whole cavity here, and then I'll show you how it eventually gets out this little hole right here. But anyway, the key thing to know is that bass comes from the dynamic driver and this balanced armature, and it mixes inside this cavity, and then it goes through a little dampener and out the front of the nozzle right here, and then into your ear. And so this whole design is sealed, and there is just a little bit of pressure. I wouldn't call it pressure buildup, but this is a sealed design, so there is just a little bit of pressure. And then here we see our below this balanced armature, we see our 2389, and then this is our E50DT. This is our dual tweeter, so it's two balanced armatures. So 1, 2, 3, and 4. So this is a dual tweeter, single mid BA, single mid bass BA, and then our dynamic 4 bass. And then right here on the side, you'll notice we have our crossover PCB. Now, this is a very expensive IM to produce, because not only are the materials very high quality, so everything about this IM is high quality. Okay, and this is one of the reasons why I wanted to highlight this IM, because I kind of feel bad about it. I understand that's just the nature of products. It's, if it's not great, people are gonna say it's not great. But anyway. But I wanted to highlight the design because it is very nice, and I want to give the engineers credit for what they did. So anyway, so we have two capacitors here, and I'll kind of point out which one's which. So we have, see if I can zoom in on there. So we have A106 and A226. So the 106, I believe, actually let me just double check, because I think we got one on the back too. No, we just have a resistor. Okay, so the 106 is for the dual tweeters, and that is actually a relatively low value. This is the reason why the upper mid and the lower treble area is as loud as it is because of this value right here. Realistically, they should have went for like a 224 or a 486 or a 105, anything lower than this value here. This 106 is too much. And then we have the A226. Now this is for the 226 is for the mid balanced armature here. And that is perfectly acceptable. The 226 is fine. It is a little bit on the low side, meaning it does allow a decent amount of like mid bass through for the amount of mid bass that this thing puts out. So ideally, this you would want to be like a 105, and you want this. I'm sorry. Ideally, you want this one to be a 105, and this to be like a 224, or like I said, what is it, a 486 or whatever it is. Anyway, And then we have 2 resistors here. Now I assume this is, I believe, a 10 ohm. So I'm not sure which one that's for. And then we have another one on the back here. I believe just one, yeah. And like they even put conformal coating on the back, which is really just nuts. And then this is a 7R5, so this is a 7.5 ohm resistor right here. So this is the whole crossover frequency divider for these 2 balanced armatures right here. This one is being played in full range, but because it's in this cavity and it's not directly coupled to the tube here, this nozzle, you're not really hearing much of the mid and treble from this one here. Realistically, all your mids and treble are coming from these 2 balanced armatures here, and then this one is just for the majority. This is definitely doing some mids too, and so is the dynamic driver, but not nearly as much from the dynamic driver, and I'll show you why in a second. But anyway, there is some mids and mid bass coming from the 17A003. So anyway, so that is the design. So bass, mid bass, mids, and treble. Now let's take it apart. I'm going to pause real quick. I'm going to start pulling stuff out, and we will talk a little bit more about it. All right, so this is the dynamic driver. All right, this is, let me actually just pop this back in real quick. I'll just show you guys how this works. All right, so this is the top of the IM right here. This is the top of the IM right there, okay? So this is where the dynamic driver sits, or actually like this, okay? So it sits like that, all right? Now, this is the front. There is a 3D printed, just a little flat disc. It's like the easiest little thing that they made. It's literally just a flat disc of resin, and it's just glued on to the front of the driver. And then here's our tube. So our tube, it's like custom cut, and it covers up this hole right here. This is a vent hole, okay? Now, the reason why this comes out into a tube and vents outside the IM is because if they were to just to slap a dampener on here and leave this be without this tube here, it would cancel out the sound that is coming from the front of the dynamic driver, because you got to remember it moves in a back and forth motion. Okay, so every time it's excurting, it's gonna make a energy wave or whatever. Okay, or a frequency wave, and that's going to emanate out, and then when it pulls back in, there's going to be rarefaction inside the cavity, but it's going to be expelling air out this tube every single time it pulls back in. So when the driver goes back in, the air gets expelled out this tube and outside the dampener. Now what the dampener does is it restricts the airflow. So the higher the value of dampener, the less air can move, meaning the more controlled the dynamic driver is. So without this, it's just free to move as much as it wants, or as much of an ability as it has to move air freely. Okay, but by restricting this tube, you're restricting the air flow that's going through the backside of this driver. So every time it excurts, air is being drawn in, and then it's being restricted through this little dampener here, and then it's making its way into the driver. Same thing when it's moving back, it's pushing air out, but it has to fight against this dampener. So the higher value of dampener, the less amount of volume that you have with the dynamic driver. So that is that design. And then this portion right here, the reason why this hole is so tiny is it essentially acts as a bandpass, and it's blocking out higher frequencies. Now, lower frequencies inside of an IM work much more like a pressure wave, and so you're still getting the bass because it's just pressure moving in and out, but the higher frequencies tend to be blocked because Lower frequencies are much less direct. They just bounce around wherever, and they'll just keep going and going and going and going because the molecules are just kind of smashing into each other. But when you have higher frequencies, that energy becomes much more direct. And so having this small hole here, it blocks a lot of the high frequencies. Now there'll be some lower mid frequencies. The larger the wave gets, the less it'll be blocked by this plate here. Okay, so essentially this allows bass to pass through because they're just big, large pressure waves, but higher frequencies will not pass through. All right, and here is inside the driver itself. Now they said it's liquid silicone, but that's not entirely true. I don't know what the material is that this fiber is suspended in, but this is a biofiber driver. So there are like a lot of little like carbon fibers all over it. I'm not gonna pull it up, but I have a bunch of pictures under the microscope, and it's just a biofiber DD. But yeah, it's a very nice quality driver. It's a very high quality dynamic driver from the looks of it. I mean, it definitely does not look cheap by any means. And I've actually never seen this housing before, so I don't even know this model. Like, I don't know the factory that makes it. I know very little about this driver because I've never seen another one like it. But yeah, it's very nice looking. I mean, it's just the golden plated shell, like that's usually more expensive. It's got this giant magnet on the back. You can actually see some of the magnet protruding out this little dampener hole. But I mean, that magnet is huge. It takes up this whole space right here, so that's a big magnet. But anyway, yeah. So that's the dynamic driver. And then here is our 17A003 by Sonyan. These are actually pretty decent mid BAs. I was using them in one of my designs, but I ended up blowing one somehow. So apparently, I mean, they're very sensitive. This is probably the loudest balanced armature in this entire setup. And this is probably the most sensitive balanced armature in the entire setup. But yeah, these I blew one, and I'm like, dang, this thing is so huge. I mean, this is bigger than the 29689. This is just a little bit smaller than a typical 22955 or like a dual Sonyan BA. It's just a little more or a little less than half the size of a dual Sonyan, and it's just probably a little less than a third the size of a 22955. All right, so then this is what we're left with. So this is some of the CNC machining, and you can see obviously the inside is a lot more raw. You can see all the various passes, the tool marks. But I mean, this is not cheap. To machine these shells, this is very expensive. And you can actually see some of the tool paths on the outside of the shell. You can just barely make it out. You get it in the right light, yeah, you see it right there. Line, 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 line. But yeah, this is very expensive. This is not cheap to manufacture. And then paint it, and then screen print it. I mean, this is not cheap. But anyway, yeah, it's a very, very beautiful shell. Very nicely built shell. Very high quality tooling path. Yeah, it's very nice. So anyway, so here are the three balanced armatures that are left. And then this is the pathway. So you see this little Knowles style dampener here. This is where the bass eventually ends up. So dynamic driver here, balanced armature here, and they kind of swirl around and mix around in this shell. And then they eventually make their way into this dampener right here, which cuts down on the mids and the treble even more. Okay, so this takes the mids and the treble and cuts it down even more because it restricts the airflow. Only the larger pressure waves can pass through it. And it eventually ends up through this little hole right here to the left. Okay, So I'm gonna try to push this out. Now this is a pain in the butt to get out, but I'm gonna do my best. So bear with me just a second while I get this out. All right, guys. So these are all the pieces of the puzzle. So just to recap, we went over the dynamic driver, how it works, the mid-bass balanced armature. We have our frequency divider here with the two capacitors and then two resistors. We have our beautiful CNC machined aluminum shell. You can see this little plug right here. So this is where those balanced armatures go in. And then here's the outside without the without that little plug inside it. Okay, so you can kind of see through it. All right. So there's a better look at the inside. So there's some glue. That's just glue. That's glue. There's some glue on the sides. So these are all hand assembled, and this is one of the reasons why this IM costs as much as it does, and I'm surprised it doesn't cost even more, is because of all this assembly here. I mean, this is not cheap for them to assemble. So anyway, but yeah, that's a lot of hand assembly. So there's that. And then this is the key piece right here. This is the remainder of it. Now you could technically make an IM with just this right here. Sorry, what did I say? 2389. This Sonian 2389. This will gladly do mids and bass on its own, and it'll actually sound pretty good. And then you have your E50 DT right here. So this would make an excellent 3 balanced armature IM, and probably get some pretty nice treble response out of this. But anyway, so we'll take a close look at this. So this is 3D printed. Now the glue that they are using in this is insane. It is like rock solid. I don't know if they just used resin, because a lot of times I'll use resin in my IMs to seal everything together because it's not coming apart. I mean, resin, glue, what does it matter? The only thing is that resin doesn't offer very much shock protection. Normally I use this kind of stuff. So this is called Fix-All adhesive. I get this stuff from the dollar store, but essentially what this is like a rubber adhesive, and it's super pliable. It's super stretchy. It is really good stuff if you are using like a dynamic driver or whatever. I can't actually do. I got some on the top here. Yeah, so you can see it's really stretchy. Now this this little blob on top isn't cured all the way, but I mean, look at those properties. Like that is very good for like shock protection, and that's kind of some of the stuff you want to look for in mounting a dynamic driver. But yeah, so that is excellent stuff for mounting drivers. The only problem is it takes forever to dry, and it smells, it stinks to high heaven, and it gets everywhere. It's not easy to work with, but it's cheap, and that's the reason why I buy it. But anyway, but yeah, so here is we'll take a little closer look at this 3D printed assembly. So this is our tube that the bass comes into, and you see it also does like a zigzag. Now that little zigzag there, that also cuts down on the treble and the mids. But yeah, it's really neat little design. So anyways, bass comes in here. So the driver's mix comes through here, goes down and across again, and then comes out this little hole right here. Okay, and that little hole, like we talked about earlier, that acts as a bandpass that only allows the bass through those big pressure waves, but it cuts down on anything that's higher frequency. The energy dies before it can even come out of the hole. So and then there's our mid and our treble balanced armatures. So you see 1, 2 right there, and then our mid range right there. But yeah, very simple. This part of the design is just like stupid easy. But yeah, and then the way they printed this is actually kind of interesting. So the supports are right here. This is, you can see the dots where they broke off the supports for the 3D printer. So this was probably just a normal, not even an industrial 3D printer. So you see the shiny parts? That was a support, 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 all the way around. Those were where the supports were broken off. And I assume that's to keep this part of the surface as flat and uniform as possible. So when the BAs mount in, they're not like, you know, crooked or anything like that. But yeah, so they actually printed it. They actually printed it this side first, right here. Now I don't see any supports on any of this, so I imagine I'm not sure. Maybe the overhang wasn't that much, or maybe they had like a support going somewhere else and I just can't see it. But yeah, and you can see the profile right here of this like little lip going around. So you can see how far this sits into the shell. So it's about 1 millimeter depth that this little plastic housing sits in the shell. But yeah, so plastic, not silicone. Same thing with the driver. They say it's liquid silicone. It's more of a biofiber composite. It could have silicone in it, but yeah, very nice. So anyway, so all that being said, I'll pretty much leave it at that. I'm not going to tear this down any further. I'd like to leave it the way it is because eventually maybe I'll try to reassemble it. The other unit I did take apart and I destroyed it. It's like not coming back unless I print one more of these and buy these two. Actually, I think all three balanced armatures I need to, well, maybe just the two. But anyway, it would take some work for me to bring it back to life. But anyway, I just felt prepared to share that with you guys because I thought that would be kind of interesting. So anyway, that is the Hidizs MS5. Hidizs, if you see this, I'd just like to say good job to your engineers. I think that the tuning could have been a little bit better, and I think next time it'd be best to reach out to the community first before you release an IM like this. It's always nice to reach out to people that you can trust whenever you're doing your prototyping. That way you get good feedback. You know, maybe they did. Maybe it was a different country. That's the thing is a lot of different countries have different tastes too. So some companies that I work with, whenever they send out prototypes, they'll send prototypes out to people in Singapore, or they'll have some people testing in China, and they'll send some to me. So like I'll be testing it, and they'll send some to other people in different countries, and that way they can kind of get an idea of which area is going to like it, because it may just be a certain exclusive product, you know, to a certain part of the world. So, but anyway, guys, I will catch you later. I'm rambling, and this video is 30 minutes long, but there you go. That is what's inside, and that is sort of the basics of the tuning of the MS5. So, see you guys. Have a good one. Peace.